were not able to make it to the Zoom class. So basically, you see this right here, 1.2, 1.2, 1.3. I want to try and cover this today, right? In 20 minutes record time, right? Um, so we'll investigate the factors that might affect the period of a simple pendulum, and we'll get into what is a simple pendulum.
Right, sir. Wait 1 minute. We must write it.
No, everything
Oh.
here will be posted on Google Classroom. You can go ahead and you'll get it at your convenience. It's just your notes. You're not required to write any notes, and you must use graphs of experimental data from simple pendulum. All right, let's go. All right, so what is a simple pendulum? So a simple pendulum is essentially an experiment that consists of a small mass hanging from an inelastic string, right? It's important that this string is inelastic, right? And we'll get into that in a few minutes, but it has a length L and it stretches from here. So this length is length L, right? And all right, we have some more persons coming in. Okay, so what happens is that if we displace string, say at 15 degrees, on this side, um, you will find that the string and the pendulum will go to the 15 degrees on the other side, right? So if we hold our bob here and we release it, right, at 15 degrees, this is our bob, we hold it, it will go over to this side, right? You see it swinging back and forth. Then it will return back to its original position like a cycle. So we call that one complete oscillation. All right, let me go over that again. All right. So one oscillation is defined as the bob moving from a displaced position and then returning back to its original position. So we have our bob here, say at 15 degrees, and we hold it here. We release it, the bob will go over this side, and then it will swing back over to this side. We call that one oscillation. And the period now, the period of the pendulum is the amount of time that is required to complete one oscillation, just one oscillation, right? So the time it takes for the bob to move from here, go over here, and then return back over here. All right, so if you're understanding, just type in the chat, yes, sir, or you can turn on your mic and say, yes, sir, I understand, I'm following.
Yes, sir. I understand.
Okay, beautiful. If you have any questions, please feel free to interrupt me, right? Or raise your hand in the chat. Okay, moving on. All right, we have some more persons coming in, Mr. Alec. All right. All right. So, all right, Mr. Brown, you have a question?
Sir, not to understanding, sir. So.
All right. So you're not sure if it's Wi-Fi. You're not understanding, Mr. Brown?
Yes, sir. I not understand.
All right. Let's go back over it again. So, the simple pendulum, right? This is an experiment. The entire simple pendulum is an experiment. Wait, let me just check the chat. What is happening in the chat? This is the class, and we post the material on Google Classroom. Everything will be posted on Google Classroom.
Sir, last not a question, sir, but a statement, sir. Sir, can please speak in the some with the earphone or some, sir, cause me barely hear you.
All right. That's Miss Johnson. Okay.
Yes, sir, Renika.
Is this better?
To your mouth, sir. Put it up to your mouth.
Is this better?
Yeah, that better, man. What you
All right. I don't want to be deafing anyone else. All right, the code will be sent. Everything for Google Classroom will be sent in short order. Right. Yeah. Along with the links for this session right here. So, for Mr. Brown, you say you weren't understanding. So, all right, we have one more in the chat. All right. Okay. Good. Yes, you'll be added to the group, Miss Johnson. When everything is sorted out, I will add it to the group. Don't worry about it. So the simple pendulum, Mr. Brown asked me to go over it again. Is an experiment where we hang a string. We have we say, let's hold the string right here with our hands, right? We hold the string and we attach a mass to it. We attach a mass to it and we hold the mass at 15 degrees, right? To hold the mass at 15 degrees over this side, you will find that there is a swinging position, right? The mass begins to swing, right? And we can do a short experiment, but after this, but let's just try and allow Mr. Brown the opportunity to understand. So we find that the mass begins to swing, right, from side to side. What we call one oscillation, or check the chat. Sir, if you're reading so dead, sir, maybe that's the reason. All right. I'm going to try my best to accommodate everyone. Please be patient. Okay, Miss Kitchener. All right. So, um, right. So we attach the bulb here and we let it go at 15 degrees. You'll find that the bulb begins to swing. Now, one oscillation, we defined one oscillation as the bulb being held at this area here. We hold the bulb. Say before we let it go, we hold the bulb at this area. When we let it go, the bulb will go over this side and then it will return. We call it one oscillation or one cycle, right? When the bulb turns like that, we call that one cycle, right? So you'll find that it will take some time for the bulb to go over here and then return back. That's what we call the period of pendulum or the period of oscillation. So it's like a cycle. It is going over here and then returning back, going over here and then returning back. Right? That's one oscillation. So let me just count and just give you a better understanding, right? So we hold the bulb here, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so that was 10 oscillations. We wait until the bulb go over here and then return back. Are you understanding better now, Mr. Brown?
Yes, sir. May I get there now?
Okay, wonderful. All right, so what? We have some persons coming in. And let's check the chat. All right, great. Okay.
Sir, just teach no, sir. Stop. Check the chat. Stop. Come on, like topic. Just teach.
I have to make sure that everyone is on par, right? I have to make sure that everybody is up to speed with what is happening. All right, let's move on quickly. Okay, so we have what factors now? What factors actually for the person who has on the mic, I'm going to have to mute you, right? All right, so what are the factors that actually affect the period of simple pendulum? The amount of time it takes for the bulb to move from here, come over here, right? And then to return back to its original position. So we will find that the length of the string affects the period of the pendulum. The amplitude affects the period of the pendulum. The amplitude is essentially that 15 degrees that we spoke about. So the amplitude is the angle that we place the pendulum at, right? And the acceleration due to gravity. We will speak more on this in the future, but I just wanted to get the idea that the length and the amplitude affects it. The final thing is that the mass does not affect the period of the pendulum, right? Okay, so the mass of the bob does not affect the period of the pendulum. It has no effect on it, and we'll do experiments to prove that right now. That's how we're going to try and end the class today. Right? Let's see what's happening over here. Okay. All right. So we'll do experiments right now. Let me pause and go over to the simulation now. We're going over to a program that we can use to prove this, what we just learned a while ago. That the length affects it, the angle affects it, the and the mass of the bob does not affect it. Right? We'll prove that now. Just bear with me for a few seconds. So we'll try and finish everything for next week. We've reached very far in the short time. Remember, if you have any questions, please let me know what is happening. Okay? If you have any questions, you can send it in the chat or you're free to
Sir,
interrupt me. Go ahead.
so why is the Bob so popular, sir? Everything is about the Bob. I don't
Because
really get the Bob situation, sir.
that it is important, right? But what is more important is that we will use it to for some calculation in the future. So the bob is important because it
I
it
just
will
you
help
name
us.
it the Bob, sir. It's overall name.
That's the name of it. Or you can call it the mass. All right, let's move on. Bob is not a person. Move on. You guys are wasting my time. All right, let's move on now. So let's go here over to our program. Please let me know if you're seeing this. Say yes, sir, no, sir, in the chat.
Yes, sir.
Okay, wonderful. All right. So we have our mass here, and this is our bob, right? This is not bob. This is a bob, right? A mass of length 1 kilo of mass 1 kilogram. The length of this string, the length of this string is, let's put it at 0.5, right? Let's put that 0.5, and we have our stopwatch over here. Say we place this amplitude, remember that word amplitude or angle, we place it at 15 degrees, right? We'll pause it and just give it some time to settle. All right, everything is okay. Length, mass, the gravity, we're on Earth. We'll go into that in the future, right? Gravity, the acceleration due to gravity. You'll learn more about that. We'll try and cover that next week. And there's no friction, right? No non-friction. All right, let's move on. So we allow it to run for a few seconds. Remember, we wait until it reaches over here and then it returns back. That is one oscillation. All right, it will happen. Let's do it slow motion first, right? All right, that's probably too slow, but okay. So it's coming back over. So we'll start the stopwatch now. So we wait until it comes over here and then it will return back. So it's 15 degrees in this area. So that's one oscillation, right? Wait until it goes over here and then it comes back to the original position. Remember the original position is here. That's two oscillations. I will just continue at normal speed, right? After this one. So we'll go over there and then when it returns, three oscillations, right? 4, 5, 6, 7, 8, 9, 10, right? We stop it at 14 seconds, right? 14 seconds. Now let's change the length of the string. Let's try and change the length of the string. So let's put the length at say no, not so much, 0.9 meters. And we place it back at 15. So this value here is 14 seconds. Let's see what happens to it. If we increase the length, what will happen to the time it will take to complete the oscillations, right? So we allow it to run, we reset our stopwatch, and we start it here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we realize now that if we increase the length, what will happen?
The length affect the period of the sum of the pendulum, sir. How
Right.
long it takes?
How long it takes? Perfect. Perfect. That's what I want to bring out for the rest of this class. All right, we see a chat coming in. Okay. No, sir. Well, I believe this was before. Right. So let's move on. So let's put it back. Remember that it was at 14 seconds first. Everybody up to speed. You can type yes, sir. You can use your mic. No, sir, if you're not getting it.
Yes, sir.
Yes, sir.
All right, great. And let's put it back up to 0.5, right? And we're changing the amplitude now. The amplitude, remember, is the angle that we're at. So it was initially 14. Mr. Lamar is coming when we're about to close, right? And you're going to say the closing prayer. So it was at 15 degrees first. Now we'll move it up to 40 degrees. Let's move it up to 40 degrees and see what happened. It was at 14 seconds first to complete 10. So let's see what happened. We reset this, right? And we start our stopwatch. Mass doesn't change. Okay, let's do it. Go. So we wait until it goes over to this side and then we start. Start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So it was originally 14.1, right? Now it is 14.55, right? So 14, you have a little 0.4 seconds difference, right? Now we'll try and change the mass of the bulb and see what happens to it. So when you increase the amplitude, the amount of time it takes will also increase. We'll do this again next week. We'll do this again for next week's class. Okay, so place it back at, so remember the original one at 15 degrees, it was at 14 seconds, right? So we'll put it back at 15 degrees, 14.1 seconds, 15 degrees, and we'll change our mass, right? You realize that the mass is getting smaller, right? We'll see what happens. Reset, and we'll start now. Okay, give me a second. Let me fix this. Almost out of time. We have 1 second. We have 1 minute to go. Let's just do this. All right. Start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right. So it was at 14.1 seconds first. Now it is at 14.16. So a very small difference. It's still at 14.1, right? So we can see, sorry about that. We can see that the mass of the bulb does not really affect the period of the pendulum, right? But what affects it is the length. Let's go back to our slide. Let's go back to our slide and then we can go to today. So what really affects it is the length of the string, the amplitude, and the acceleration due to gravity, but the mass of the bulb doesn't affect it. Oh, let's do that one before we go. Yeah, let's do that one. The acceleration due to gravity. So the acceleration due to gravity is based on where you are. So on Earth, right, you will have a higher force. You will have a higher force of gravity than if you're on Mars or you're on the moon, right? We'll talk about it next time, but just know that the acceleration due to gravity changes. Acceleration due to gravity changes based on the planet that you're on, right? So let's say that we're on, we put it back up, we put our mass back at 1, and we stop our stopwatch, we pause it, place it back at 15 degrees, and we run the pendulum, right? So we start here, start, 1, 2, oh wait, that was at 14.1 seconds. So we change this now. Let's say we're on the moon. What would it be like? The acceleration due to gravity, right? Let's go. So you realize that the pendulum is moving a lot slower, right? So that's 1, 2, 3, 4, 5. You can look at the time and realize that it passed 14 seconds a long time. 6, 7, 8, 9, 10. Right? You see that it's much slower. Almost 30. It's almost 35 seconds. Right? I've stopped that a little late. All right. Let's say we were on Jupiter. Right? You realize the pendulum is moving a lot faster now. Right? Let's place it at 15 degrees. Let's set it to play, and then we start. Oh my God, I can't even keep up. All right, let me go in slow motion for a second. Right, restart. 15 degrees and play. Right, so wait until it goes over and come back over here. So go. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, so that takes 9 seconds compared to 14 seconds. Right, so
Sir, it would have been exactly 9 seconds. I must say I have on slow motion first, you know.
no man, it would be 9 seconds. The slow motion also slows down the time. See, it's like the time is also slowed down. Everything is proportional, right? And when you increase it back, it increases the time again, right? So, that concludes the class. We're 3 minutes over the time. Let me stop sharing. Okay, so for next week, all right, I'll take a picture of. All right, you know what? Send me your names, the full names in the group of who is present today.
Sir, treasure member me in the group, you know.
Yeah. I'll write down your name.
Okay.
Yeah, man. I'll take a picture of this also. Right. So have a wonderful day, everyone, and I hope we get this started up by next week.
You too, sir.
All right. Goodbye.
Hey, come on.